Hi everyone, my name is Hassan and I'm here to give you a complete tutorial of using KNN in MATLAB. First of all, let me introduce you. I am a MATLAB teacher for more than 15 years of experience, but most of my courses is in um, uh, Persian language, but it's the first time I am going to develop a course based on English language. So I really appreciate your patience to regarding my mistake in language. So you can contact me via email and also Telegram ID. This is my website and this is my channel in Opera. It's the national Opera like YouTube in my country, and this is my Telegram channel. So let's start uh, with the KNN classification or KNN classifier. The first of all, it's worth to mention it. The class KNN can be used for two purposes: for classifier, classification, and regression. But more than 90% of cases, the people, the students, the researchers use it as a classifier. Okay? So it's really popular as a simple and efficient classifier in machine learning. So I decided to give you a great tutorial to use and implement KNN in MATLAB, and all of you need to know about this classifier for uh, working in MATLAB. First of all, you need a data set. You can load your data here. So I choose a Fisher Iris dataset. It's the popular data in classification in machine learning specifically. It includes four features in um, 150 samples. Let me load it in MATLAB. You can use it. It's better. We have four features and 150 samples. It's important to load your data in this syntax. It doesn't matter. It it can be cell variable, it can be double variable, it doesn't matter. But it's really important you prepare your data, your features as a column and sample as a row. Okay, it's really important. So means is a feature matrix. We call it X, and uh, a species we call it Y as a target. So it's a uh, also this dataset contains three classes. It means it's a multi-class dataset. Okay, it means KNN can efficiently work in dealing with binary class and also multi-class. So it doesn't matter you have what number of classes in your data. KNN can handle it. Okay, and after loading your data, we should prepare our data. Specifically, we should split our data into testing and training. Training for train the model and test to evaluate the trained model. Okay, it's really important. We don't allow to use the test data in the process of training. We should keep the test data besides, and after training the model based on training data, finally we can test our model based on testing data. So it's really important to don't use the test data in the process of training. There are many here, absolutely. Here there are many ways to upload your data, to load your data to workspace. Load data is simple and useful data for loading data with .mat. And there are lots of useful command to load your data in MATLAB. For example, XLS read specifically is for Excel file, or you can use import data command for general data, for example text, Excel, image, and other types of data. Import data, let me write it. Import data, it's a general command for loading your data, or read matrix, also XLS read. It's a actually it's an old version of command. It was really useful when I used for example 7 years ago. It was really useful that moment, but now read matrix and import data can handle Excel files, or other types of data. They are really functional in the latest version of MATLAB, actually 20 and 24 version of MATLAB. Okay, so there are many ways to upload your data to MATLAB. And also there are many ways to split your data into training and testing. You can, for example, use rand perm command as a shuffling method data, shuffling your data and then split it in training and testing. Or simply you can use CV, cross validation partitioning. Okay, you can the first input is your actually target, the whole target, and we can use here hold out is a specific method to split data, to select the data. It means we have a specific percent of each classes in training and testing data. To elaborate further, when we set 0.3, it means that 30% of data is chosen for testing and the others for training, and also 30% of each classes. And it means equally we select the 30% of each classes for training and the others for training. Okay, it's really sensitive in this case. It doesn't mean we select 30% of data generally. We have a look to the sample of each classes. It's really important here, and really it's a really standard way, is the standard method to split the data for training and testing. Okay, let's go to the next step. Please ignore this part. This is a pre-processing. and many ways you can pre-process your data to improve the accuracy. For example, outlier detection, imbalanced, many classifier data classification problems suffer from the imbalance. It means the distribution of classes is not equal. We have, for example, in a data 90% in one class and the others in the other class. It's unequal balance. So we call it imbalanced data. So it's really important to handle the distribution of data before we go to the train part. And then normalization is really important. It's really popular method. First of all, many students, many researchers decide to normalize their data before they go to the next step. And also similarly, standardization is really similar to normalization. They are in the same concept, normalization and standardization. And the important one, more I highly recommend this pre-processing. Feature selection can really help to improve your accuracy, improve your efficiency of algorithm. Select the best subset of features of your features and then classify based on your best and optimal subsets of features. It's really important and can really affect on the outcome of your modeling. So we ignore the implementing these methods because our main focus here is classification, specifically KNN. So the first step, loading data, and the next step is dividing or splitting data into training and testing. And the second step is here is training the model. There are actually, if I'm not mistaken, 3 methods to use KNN, but the main and standard function in MATLAB is fit KNN. Fit is fitting model, means fitting model. C means classification, and KNN the name of classifier. It's the standard syntax in MATLAB. For example, fit K SVM. You can use in this way, the same way here for classifying SVM, classifying bit SVM model. Okay, so it's a standard command to use for KNN for classification. And so I really recommend you to read the help of this function. It can be really helpful and beneficial for you. There are lots of details you should know about it more. So please read the help of this function in MATLAB. You can search it here, fit KNN, and go to the document of this function. Okay, let's continue. The two first inputs of this function take xtrain and ytrain. Training data, features of training data, and target of training data. And it's really important to set, you can use it without these settings. You can use it simply in this syntax without setting any parameters, but it's really important to set these two important parameters. Number of neighbors is the first and main important setting in KNN setting parameters, and the metric of distance. There are many distance metrics, so you should try with different type of metrics here. They are really important to achieve a higher accuracy in the test data. Generally, they changing this variable, changing these parameters can help you to achieve a higher accuracy. KNN is highly sensitive to these parameters. There are also other parameters you can set here, but distance and number of neighbors is highly important. If you change, for example, number of neighbors from 2 to 3, maybe you can receive a different accuracy. Or there are lots of options here for distance metric. For example, city block, correlation, cosine, Euclidean, Hamming, Jaccard, Mahalanobis. There are many, more than 7 or 8 metrics that you can use it for classification with KNN. So I use it this metric because it's really popular and standard, and usually I receive a better accuracy with these settings. But for different data, maybe you have to change the distance metric to achieve a higher accuracy. So it's really important we have two important parameters. They are really key in modeling KNN. Now, number of neighbors and distance metric. So after training, we should predict based on the train model and test data. The predict function is the popular and prevalent function in MATLAB for predicting the results of the train model for many types of classifier, regression, both machine learning algorithms and deep learning algorithms. You can use predict for all of them. For example, we can use it for SVM model, for multi-layer perceptron model, for random forest, for example CNN, for LSTM, for all of them. This function can handle all type of model in machine learning and deep learning. So the first input is back to the train model. We should put the train model here, and then the feature of testing data, only feature of testing data. And there are many actually optional parameters. If here ignore them, but there are options for setting parameters here because they are not really important here. Okay, and the output of this function is yPredict, the prediction of these features based on this model. based on the trained model. Okay, so here we predict for testing data on trained model, and the final step is the evaluation or plotting some uh, figure for better visualization and understanding the output of the model. For example, here I calculate the accuracy. One of the actually the most important metric for classifier, for evaluating the output of a classifier: accuracy, general accuracy or overall accuracy. Accuracy means sum of the number of accurate predicted data. Let me put it another way. We count the number of predicted data that we correctly predict them, divided to the whole number of testing data. Means accuracy. How many of testing data we predict them correctly? How many? This number divided to the whole number of testing data, and this is the accuracy. And the most important plot in classification, the output of classification in confusion matrix or confusion chart, and we can use this function, this functional function, confusion chart, and it take two input: via test, target of testing data, and via predict, that we here calculate this variable. Let me run this code completely and see the output of our data. Okay, and here we have the accuracy, and this is the confusion matrix for KNN classification or confusion chart. Predicted classes. From this direction you can see the output predicted class, and in this direction you can see the true classification. For example, it means there was a 15 number of samples in Setusa class, and the algorithm completely predict these 15 numbers in Setusa class. Completely predict these classes. It's 100% in terms of these classes, this class. But these two classes or the other two classes, there are some mistake here. For example, versicolor classes contains 15 classes, 15 samples, while one of them the algorithm, our trained model, they predicted one of them into the final classes incorrectly. Okay, so this is the confusion matrix, and let me review and review the two sensitive parameter, two important hyperparameter in KNN. For example, I change the number of K's from 2 to for example 5, and then run it. Okay, the accuracy goes up, and we have here a better visualization. In the previous one we had 2. For example, if we had 2 incorrect predicted, incorrect prediction, and only with changing the number of neighbors we achieve approximately 2% in accuracy, 2 higher percent in accuracy. Okay, so they are really important. And let me change the distance metric. For example, I want to use Mahalanobis. Okay, and run then. See, we have different results. We lose again 2% in accuracy. So they are really important. These 2 metrics really important to the in KNN classifier. We should make sure to set this parameter accurately regarding my data, our data. So there are efficient way for setting these 2 important parameters. First of all, you can use manually and change them like everything I did here, but there are an efficient and efficient method to set these parameters. We can use meta-heuristic algorithms like genetic algorithm PSO and find the optimal parameters of number of neighbors and distance metrics based on that meta-heuristic algorithm. It's an acceptable and standard way to set these parameters. It's really important to, for example, you are writing a paper for international journal, so they don't accept that you set this parameter manually. When you use, for example, with meta-heuristic algorithm as a smart and intelligence methods, it can improve your paper. So it's really important to set this parameter in a standard way. Okay, this tutorial finished. I hope it be really helpful and beneficial for you. For if you follow me, it's really important, and it is a motivation for me to provide more courses in this case. Please, so please follow me. Thank you so much. Bye bye.